Hello, welcome to all. Now I am going to discuss about Hofmann rule and Saytzeff rule. Then, uh, then we'll see what is Saytzeff rule. What is Saytzeff rule? The elimination reaction in which the product form will be the most substituted alkene. In the elimination reaction product form will be the more substituted alkene. Then we'll see. We'll take an example. Here I have taken this reactant, and here we'll see when we treated with this compound with base, it will abstract this proton because this is alpha carbon and this is beta carbon. Also here this is beta carbon, and it can abstract both of these proton at a time. It will abstract it can abstract this proton, and also it can abstract also this proton, and here will be possibility will be two possible product will be formed, and here in the first case it is abstracting this proton, and in the second case it is abstracting this proton. Two products are forming compound product 1 and product 2. According to Hofmann rule, the most substituted product will be the major product. Here which one is the most substituted? This one will be the most substituted, and this one is the less substituted. According to Saytzeff rule, this will be the major product. Why this will be the major product? Now we will see why this one is the major product, and we can easily understand why this most substituted product will be the major product by this transition state theory. Here this transition state showing that this transition state showing that this base is abstracting this proton, and here at a time this double bond is forming, and at the same time this bromine is eliminated, and giving this alkene, most substituted alkene. And here in this transition state showing that this is more stable as compared to this one, which I will show in the energy profile diagram. And here it is showing that this is the here abstracting this base is abstracting this CH3 proton, and here this double bond is forming, and bromine is leaving from this carbon atom and forming this compound 2. Here this is the transition state, and we'll see in the energy profile diagram. And this transition state can be easily understood by this energy profile diagram. It is showing that this is the transition state for this product 1, and this is the transition state for the product 2. and it is showing that this product 1 is more stable as compared to that product 2, and this energy, and it is showing in the energy profile diagram. And for this transition state 1, a lower energy required and the product is forming, which is more stable. And for this transition state 2, the transition state required more energy, and also the product form is more unstable. That's why it is forming more substituted product. Then I will discuss about what is Hofmann rule. So we'll see what is Hofmann rule. In the elimination reaction, the product form which is less substituted alkene, and also compound containing bulky leaving group like quaternary ammonium salt and sulfonium salt will obey the Hofmann rule. Compound containing bulky leaving group such as quaternary ammonium salt or sulfonium salt will obey this Hofmann rule. Then we will see one example. This is this is let's take a example. This is the ammonium salt, and when it is heated at high temperature, it will give this less substituted alkene. This is 95% less substituted alkene, and that more substituted alkene is only 5%. Then we'll see the some of the example from this Hofmann and Saytzeff rule. First we will see this one. And when it will treated with base like sodium ethoxide and ethanol, it will give this more substituted alkene as a major product, around 81% major product. And we'll take that this ammonium salt when treated with base and water, it will give this less substituted alkene. This one is major product, around 98% major product. And from this two, this one is Hofmann product. Hofmann products. This is Saytzeff product. Another example we'll take, that is this is the example when this molecule are treated with base, and maybe you are thinking it will form. Here is two possible. The base can extract this proton and also this proton, and here are two possible product possible, and will be the major product. And when the base is extracting this proton, and this one will be the product when base will extract this proton, this methyl proton, then less substituted product will be formed. Less substituted product will form, and maybe you are thinking this highly substituted product will be the major product, but here something deviation takes place. Actually, what happened here? Here these two are two methyl group, and bulkiness of this position is more, and preferably the transition state which is formed will be not stabilized in this more substituted product, and the transition state which is formed in the less substituted alkene will be the stabilized, and this here the bulkiness of this methyl group is the major factor for the formation of this highly more substituted product is the major product. This will form 81%, and this will form only 19%.